So we're going to do a review tonight of Economics 3100, Labor Economics, and we're going to look at the first half of the course preparatory to the midterm exam. And the items that are fair game on the exam will be labor market models and labor market structure. We'll look at marginality in the labor markets. We'll look at evaluating labor market models. We'll look at demand curves, supply relations, labor-leisure models. We'll look at elasticity, and we'll look at friction in the market. So, as I said in probably the announcement or the email that went out to say we're going to do this, I said that what I'd like you to do is come prepared to ask some questions. Because it's really not realistic for me to just go through all the concepts from this. So let's do that, and if there are then some things that I think you should ask that you haven't, then I'll fill in those as well. Okay. So, do you have a sense of the areas that you want to focus on? Yeah. Okay, so I'm going to write them down so I don't forget them. So go ahead and kind of go ahead and list some items off that you want us to focus to.
Okay. Just the elasticity and in general, everything with elasticity.
Okay.
I'm trying to rewatch everything and
okay.
a little slower with that.
And I think I can help you understand it very well. Okay. It'll be good.
Besides that, I think I'm pretty comfortable with everything else.
Okay.
I think, but elasticity is the one that I feel like I'd like to elaborate.
So I want to spend a little bit of time also in evaluating models, a little bit of time in marginality, in part because I see people lose points on the exam for not handling these in the kind of way in which I've showed in the videos in which I'd like them to. So the way that we've done these on the videos for the class, the way you've seen them in the review problem solution sets, that's what I'm looking for. Okay. And sometimes people that have had econ classes that are not labor economics will use a different convention to describe things and display things, and I'm looking for the convention of labor economics. So are you an econ major?
Yeah.
Okay. And how far are you into your program? Well, you graduate very soon, right?
Yeah, well, I've done, this is
it?
Yeah, this is it.
This is the last year now?
I actually did the whole ceremony and all last month.
Oh, good for you. Yeah. That's kind of cool, isn't it?
Yeah.
Yeah. I was fortunate to, I was old enough when I finished my bachelor's degree that 2 of my children were able to be there. Oh, and when I finished my doctorate, all of my children and some of my grandchildren, in fact, all my grandchildren were there as well, so that was kind of nice. Well, good for you. That's a cool day, right?
Yeah. It really was.
If you don't mind, let's start with some marginality issues.
Okay.
Okay? So we understand marginality to be the study of the changes at the next one or the next unit, right? And there are several relationships we need to keep in mind. One of them is the marginal product of labor, which is equal to some change in quantity divided by some change in labor units. And so let's say we have a couple of columns here where we have quantity, and quantity is always the quantity of the good being produced by labor. So it's not the quantity of labor, it's the quantity of the good being produced by labor. We have some labor units, right? And then we can think of marginal product of labor, and we can think of a few other things as we move along that same. I'm going to move those a little bit because I'm going to run out of some space there, and I don't want that. So let's assume, I just got to think about these for a minute. Let's assume that at 1 unit of labor, we're manufacturing 15 of an item. At 2 units of labor, we're manufacturing 25. At 3 units of labor, we're manufacturing 30. At 4, 35. At 5, we have 35. And at 6 units of labor, we're back at 30. Okay? So we're able to see a bit of a gamut here as we go through this. So the marginal product of labor is going to be the change in quantity divided by the change in labor units. And here we've set this up nicely so that we only have a 1 unit change each time. And even if it wasn't 1, we have a consistent change each time. That's not always going to be the case. In fact, it may not be the case on your midterm. So pay attention to this change as well as this change, okay? Well, if these two items are given, then I can start to think about the rest of this. Do I know the change from 0 units of labor to 1? And do I know what the change in quantity was there necessarily?
No.
No, I don't. You might suppose, well, at 0 units of labor, you had a quantity of 0, but that's not necessarily the case. We may have some automation going on here. We may have some other effects that we shouldn't make that supposition. So what we know is we don't know, and so that's null, okay? So the next item we have then, we go from 15 units to 25, and so we have a 10 unit spread, and we have 1 change, so our marginal product of labor is 10. And here then we go from 25 to 30, so it's 5 divided by 1. And then we have another 5 divided by 1. So this is interesting. And then we have 0 divided by 1, so we're just going to think of that as 0. I know technically it's null, but we're going to think of it as 0. And then we have actually a decline. So now we have negative 5. So that's our marginal product of labor. One of the things that you probably see is that you can be very specific about this. If you know what the change is each time here, you can actually pretty automatically fill this in.
Yeah.
But I'm going to encourage you not to do that because this change may not always be consistent. So that moves us then to the next marginality, and that's marginal revenue product of labor. Well, the marginal revenue product of labor is equal to the marginal product of labor times the price of the output good. And that's the price of the item that we have quantity for. So this would, if you know much about economics and consumer economics, that's the goods market, whereas labor is an input. So let's assume for a minute that we have a competitive goods market, and regardless of the quantity, we have some P star and it equals 5. Okay. So if we don't know what that number is, we don't know what that number is. We just can't. And in this case, P star 5 is going to be consistent at every level because it doesn't matter the quantity if we're in a competitive market, right? So now we're going to think about MRP of L equaling marginal product of labor times the price. So we have 10, which gives us 50, 5, which gives us 25, 5 again at 25, 0, not good, and then negative 25. Okay. Okay, well, what's the relevance of that? Well, we know a couple of things. We know that in a competitive market, let me do this over here, in a competitive labor market, we're looking for the point at which marginal revenue product of labor is equal to the marginal expense of labor. For those of us that know microeconomics well at all, that's the same thing as marginal revenue equaling marginal cost, right? Okay. And we know that this is a profit maximizing condition. So if we can get to this point, hire enough workers to get to where MRP of L equals ME of L, and stop there, then that's our maximum profit. It doesn't mean when those are equal, it looks like we don't have any profit at all. It doesn't mean there's no profit. There's no marginal profit anymore. So going beyond that, we're at a marginal loss, which will start to erode the profit we've already built up. So we don't want to go to that point. Okay. We're also going to see in a few minutes that this is a general market condition, but the competitive market condition is marginal revenue product of labor equaling the wage. So if the theory of transitivity holds, A equals B and B equals C, then we should be able to think of the wage equaling the marginal expense of labor. Again, it's in a competitive market condition and a competitive market condition, whereas this is a general market condition. Okay? So we'd like to get to a point where some of this is true for us, because we know that it's profit maximization. So if I'm over here and I find that in this case the wage is equal to 25, then I want to hire enough workers to get to the point where my marginal revenue product of labor is equal to my wage. But I have a bit of a conundrum at the moment. I have it equal to my wage here, and I have it equal to my wage here. So do I stop at at 3 workers? Or do I stop at 4 workers? So I have to think about that. Well, if I stop at 2 workers, then I've got MRP of L equaling W. Hi. Your name?
Claire.
Thanks, Claire. So if I stop at that point, I've reached profit maximization, but why not go further? Why not make 35 instead of 30? Because I am going to take a little bit of risk, right? If I go further, it's more effort, but no greater profitability. So why put yourself through the bother? Okay. What if it was a little bit different still? What if, in fact, we didn't have the wage line up so neatly with one of the MRP of L's? What if we found that we actually were at, let's say, a wage of 26? Okay. Well, in this case, I've got marginal revenue product of labor at 50, certainly greater than 26. I've got marginal revenue product of labor at 25, a tiny bit lower than this. So would I stop at 2 workers, or would I go to 3? What do you think, Don?
I'd stop at 2.
How come? I like more. This whole issue of being bigger is the American dream, right?
Yeah.
Why would you stop? I agree with you, by the way. I never argue with you when you're right. Okay. So why would you stop?
Well, because 50 to 26 is way bigger than 25 to 26.
Well, and in fact, if we're at 25, marginal revenue product of labor, which is what the firm gets from the worker's output, but if the cost is 26, we actually have designed a $1 loss, right?
Yeah.
It's hard enough to make money in business without designing a loss. Stop while you're ahead. Even though you're going to say, wait a minute, there's a big stretch there.
Yeah.
Stop while you're ahead. Okay? So that's one of the things to think about. Excuse me. Well, I want to take this a little bit further. I want to go ahead and take it to the marginal expense of labor. And to do that, I have to think about the total cost of labor, and then we'll consider the marginal expense of labor. The total cost of labor is equal to the wage times the labor units. And the marginal expense of labor is equal to the change in total cost of labor divided by change in labor units. So now we can see where we are with respect to this whole profit maximization thing as well. Okay? Remember, I'm going to go back over here to say that wage was at 25, because that's the one that lined up nicely for us and lets us prove our point nicely. So the total cost of labor, well, 1 times null is null, right? 2 times 10, I'm not saying this right, 2 times 25. So the wage times the labor, 2 times 25, I'm at 50. And 3 times 25, I'm at 75. 4 times 25, I'm at 100. I'm at 125. I'm at 150. Right? So I've just multiplied labor units times my wage. My wage, I'm suggesting, is constant. Well, if this is a competitive labor market, and if this model is for the firm, this isn't a model for the market, this model is for the firm, right? Because it's the firm that produces the quantity, it's the firm that employs a worker, it's the firm that gets the revenue and productivity of that worker. So if I've got a competitive labor market, such that my W isn't just W, it's W star, my wage is consistent at every quantity of labor, which is a little bit different than thinking about the labor demand or supply curves and equation, but those are for the whole market. I'm looking at a firm within the market, which happens to be a wage taker, because there's only one firm. It doesn't control wages, no matter how many workers it employs. Well, what's the marginal expense of labor? Well, again, here, we don't have one, right? And now we can say change in total cost of labor divided by change of labor. So change in total cost of labor, 50 divided by 2 is at 25.
Would it be 2 or would it be 1?
Let me think.
Could it change from 1 to 2, the units of labor?
It would be, that's a good question. It would in this case be 1, so it would be, we'd be sitting at 50?
Yeah, I think so.
Yep, you're right. You're right. So I gotta make sure that I've got this well. So I go from 0, or null rather, to 2 workers at 25, so it's at 50. So now I have to think of, I go from 0 to 50, so I've got a 50 change in total cost of labor and a 1 change, so I'm at 50 here. And now I go ahead and have a change in total cost of labor, or total cost of labor of 25, and a change of 1, so I'm at 25. Again, a change of 25 and a change of 1, I'm at 25. And as you're going to see, we're 25 all the way down. Because the reality is the marginal expense of labor, it should be constant when the wage is constant. Now we have a bit of anomaly on this one, because here we've got this 50 that's kind of staring us in the face, and it's because we jump from 0 to 2, okay? So when the wage is constant, when we're in a competitive labor market, the marginal expense of labor is going to also be constant, and it's going to be equal to the wage, which was one of our competitive market conditions. In a competitive market, the wage is equal to the marginal expense of labor. And we want to hire to the point where our marginal expense of labor and our marginal revenue product of labor and our wage are all the same. So wage at 25, we've got MRP of L at 25, we've got ME of L at 25. We want to hire 2 people and we want to stop. We reach profit maximization. One of the mistakes I often see people make on an exam like this is they suppose they know what the change was to get some values in this first row. We don't. We don't. And Claire said before you stepped in, you might suppose that if we have 0 labor units, we have 0 quantity of output, but that makes the supposition that labor is the only thing that's making the output. We might have some machinery here, we might have some automation, something that is outside of labor, maybe it's capital that is employed with labor that could be producing a little bit even without a human being interface. So that's the basics behind marginality. So if you were to observe a table, and if you have any 2 numbers in that table in a row, you should be able to find the other numbers in the row, right? If we know that MRP of L is 50, and we know that MP of L is 10, and we've got this thing over here about prices, and that's another given, right? Then we should be able to work this backwards. So think about it like that. I know that you did that at least in one of the review problems, and you saw me do that at least in one of the videos. Any other questions about marginality? Claire, what's the law of diminishing marginal return? Do you recall?
That at a certain point, by adding more labor, you'll get a smaller and smaller return from it.
Do you believe that?
Oh yeah. If you have too many people working at your restaurant or whatever, eventually they'll run out of things to do and you'll be paying for labor.
And you probably remember my very simplified sandwich shop, right?
Yeah.
So a key to this, though, is that we accept that until we reach efficient utility of our capital footprint, whatever that happens to be, we might be improving productivity until we get there. But once we get there, when we go beyond it, we're declining, right? And it's okay to decline. We don't want to decline past 0. Let me kind of line these up for you so you can see what some of the graphic looks like. If I'm looking at labor units, and I've got marginal product of labor, and I'm looking at labor units, and I've got total effects of labor, okay? So if I've got a marginal product of labor, here at, we're going to say at 1 worker, we've got 10, and at 2 workers, maybe that actually increased to 15, and at 3 workers, it then went back down to 10, and at 4 workers, whoops, it went to 5. We'll start to note this. At 1 it was 10, at 2 it was 15, at 3 it went back to 10, at 4, let's say it was 5. So we see here that the law of diminishing marginal returns is taking place. And then let's say at 5 workers, it was 0, and at 6 workers, it was -5. So now we're down here. So as we graph that, then we see that we've come up, and now we're coming down. And this looks kind of linear. It's probably really not that linear, okay? But we see it happening. Well, the total product of labor is kind of interesting. So here again, we'll just telegraph these labor units down to this little graphic. And at 1 unit of labor, we had 10. So we've got here, at 2 units, we had 15. Well, 10 plus 15 then, because we've got to, we're doing totals, so that takes us to 25. And so that's going to be here. And then at the 3rd unit, we then had 10, so that takes us to 35. Again, it's cumulative. And at the 4th unit, we had 5. And so that takes us to 40. And then at the next one, we have 0, so we're still at 40, right? And the next one, we have -5, so now we're going to decline by 5. So here's the graphic that tends to appear. It's not coincidental that the point at which we reach 0 on our marginal product of labor graphic is the apex of our curve, such that the slope of this curve is equal to 0. It's the apex, and beyond that, our total product of labor is now going south. And we don't want that. We want to stay away from it, because that's just costing us money. Okay? So now you know everything about marginality, right?
Every single thing.
Every single thing, except for all that other stuff we haven't talked about that we spend an hour or more on in the videos. We're going to revisit marginality in the second half of the course when we start to talk about monopsony. Okay, it becomes very important again. So don't think that once we get past this in this half of the course that we're done with marginality. But marginality becomes important in pay and productivity, in monopsony, in discrimination, even when we start to think about isoquants and isocurves at some point. Okay. Can I briefly go through and just do a very simple labor market model and talk about evaluations of it, and then maybe transition from there to elasticity, and then also from that evaluation point to friction. Okay? So I'm going to do this off the top of my head, and unfortunately that means I don't know where it's going to end up. But we're going to see if it can end up someplace productive. So if we have 2 equations, one that defines labor supply and one that defines labor demand, we should be able to take those 2 equations, and there's a lot we can learn. We can learn about equilibrium, we can learn about intercepts, which then lets us learn about the graphic, so the graphic model. We can learn about a table of values, and we can learn about elasticity. So those 2 equations are really very powerful. One of the things that I know people sometimes struggle with, sometimes in the review problems, almost all the time on an exam, half the class will spend time trying to plot things out very perfectly. You know, we'll do a X and a Y axis, and we go 1, 2, 3, 4, 5, 6, try to line these up nicely, make them all good, and then 1, 2, 3, 4, 5, 6, looking for the exact same distances so that if you start to plot, it looks perfectly proportionate. If you start this way, without having done the equations first, you're almost doomed to failure. Two problems. One, you don't know what the scale needs to look like by the time you're done. So I see people all the time, they'll spend time filling their page this way, and then realize that way up here at 75 is where we actually cross the y-axis with one of our curves. So don't do this to begin with. Do what I'm about to show you, and then we can, at the appropriate time, fill out the graphic. The other thing that you don't need to do with this is not an art class. This is not a class in design or architecture. This is a class in understanding whether or not you can calculate and visualize. And I'm here to tell you that if you give me a demand curve that is downward sloping and crosses both the wage and the labor axis, and you can tell me the values of which it crosses, I'm a happy guy. I don't care if it's proportionally accurate. I care that downward sloping is not upward sloping. I prefer downward sloping to not be horizontal either, but I prefer really it's not upward sloping. Similarly, if that's a labor demand curve, that might be a labor supply curve. And I want to know the labor supply is upward sloping. I don't care about proportionality. But what I do care about is the equation will tell us if it's upward sloping and crosses the y-axis, or if it happens to be upward sloping and crosses the x-axis. So if you start to lay this out before you go ahead and do the numbers, again, you're going to be eating up some of your budget. And your budget when you take an exam is time, and I think your budget probably is also some level of frustration that you can deal with before you just start to pull your hair out. And you can notice I've already reached that, so I know all about that part. So I'm just going to throw a couple of possible supply and demand curves to us. Let's say that negative 10 plus 3W is equal to 5 minus 2W. Okay? I think this is going to work out since that we like the outcomes. So the first thing I want to do is think about equilibrium. I have a problem though. I know that with two equations, I can solve for two unknowns. But I think I have two equations, and I have 1, 2, 3 unknowns. How do I think I can solve this? So I can only solve two equations, two unknowns. Well, the way I can do that is I do know, just because I've seen it more than once or twice, that at some point, the labor supply and the labor demand equation in some space, whether it's positive space, negative space, because remember this is just a Cartesian coordinate, or negative positive space, positive negative, they're going to cross somewhere. If one's upward sloping and one's downward sloping, they are going to cross somewhere. And that point at which they cross, which we're going to hope for the moment is going to be in positive space here because it'll only prove some points that I'll have a hard time with otherwise, they're the same thing. At that particular point, they're the same thing. So we think about them as being two separate variables, but at a point we know they're not. So now we have two equations and two unknowns, and that's how we can do this. So what's the first thing I would do to solve this?
Set them equal to each other.
Okay. Why do I think I can do that? There's a functional thing that caused me to know, forget the laws of algebra, I can do it because of something. Because right there, they are the same. This is LS and this is LD, and right there, they are the exact same point, the exact same thing. So there's going to be some L, and we call that L star, at which LD and LS are the same with some W. Okay? So we're about to find those. And I don't know at the moment if our labor supply is going to cross the y-axis in positive space, or is it going to cross the x-axis in positive space. I don't know. Frankly, I do kind of know, but we don't necessarily know until we start to look at this more. So let's go ahead and equilibrate them. And when I say equilibrate, equilibrating, finding market clearing levels are the exact same thing. Okay? So negative 10 plus 3W is equal to 5 minus 2W. So I'm going to add 2W to both sides. I've got 5W is equal to, I'm going to add 10 to both sides. 15. Now I'll simply divide both sides by 5, and I've got W star is at 3. Okay, so fairly simple algebra. And you can expect on an exam, just like with the review problems, that the solution of this typically doesn't get much more than this. Okay? So if I know W star, how do I find L star?
You plug it into either one of those equations.
But they're two different equations, and they create two different curves. Claire, why is it that I can plug it into either one and get the right answer?
Because it's the market clearing price, and so the equilibrium would be.
Because right there, they are the same still, right?
Right.
And if I have any questions about that, I can plug it into one of them, and I can then plug it into the other one, and I'll prove to myself that they're the same. If you plug it into one and then the other and they're not the same, start over, because something has gone awry. So we'll just go ahead and use this one. It seems to be the easy one for me. And I think I may have a problem all of a sudden. I do. Such that I've got 5 minus 2 times W. So 5 minus 6. I'm going to have then negative 1. L star is equal to negative 1. Darn. I was afraid of this. Let me see if I did that right. Negative 10 plus 3 times 3. Negative 10 plus 9 is still negative 1. So I've given myself a bit of a problem here. But we'll model it, because we don't care where it ends up for the sake of evaluation. It gives us an opportunity to discuss what it might mean. Okay? So let's do that. So I have now done my equilibrium. Now let me set up my intercepts. Do you know how to set up intercepts, Don? Are you comfortable with that?
Yeah, so you just set supply demand equal to 0, right?
Yeah, what I'm going to do is I'm going to set some labor in either of these equations equal to 0, and I'm going to find a value for wage. And then I'm separately going to set wage equal to 0 to find a value for labor. And the reason I can do that is I know when I look at this, I'm at the 0, 0 nexus here. This is my labor axis, or x-axis. This is my wage axis, or my y-axis. And anything that's on the wage axis is at a 0 value for labor. Anything that's on the labor axis is at a 0 value for wage. So I know I can find my intercepts that way. So I do this the same way every time. I'm going to take LS. I'm going to say when wage is equal to 0, then what I have is LS is equal to negative 10 plus 3 times 0, or it's just equal to negative 10. That was simple enough, right? And then I'll go ahead and say when LS is equal to 0, so what I'm left with is 0 is equal to negative 10 plus 3W, or 3W is equal to negative 10, or W is equal to negative 3 1/3. So I've now identified my L and my W for my labor supply relation. Let's do this for labor demand before we go further. So I think my equation then for demand is 5 minus 2W. So LD, when W is equal to 0. Again, I do it the same way every time. Why is that? Why do I do it the same way every time? Claire, any idea?
Of why do you do it the same
Why
way?
do I do it the same way every time?
Because why do it a different way? Why, if it's broken, why fix
Okay,
it?
there's something to that, but there's a little bit more for me. We tend to be creatures of habit. If I do it the same way every time, I don't have to think about it as much. My chances of screwing it up are less. And frankly, I have enough opportunity to mess this up, as you're about to see, because we're about to have an equilibrium in negative space. I don't need any help messing it up. Okay? So when W is equal to 0, then I have LD is equal to, I think we said what? 5 minus 2 times 0, or 5. Yeah. And when LD is equal to 0, then I have 0 is equal to 5 minus 2W. 2W is equal to 5. W is equal to 2 1/2. So again, I've now fixed my numbers. So let me see if I can plot this, because right now I have axis intercepts and I have equilibrium. I actually know 3 points on each line. I should be able to plot this thing. Okay. So I know I'm going to have a labor demand relation where I'm crossing L at 5, W at 2.5. And I know it's probably going to go a little bit further than I'd like it to. So that is 2.5, that is 5. Okay. I also know then from my other values here that I'm going to cross labor supply at -10, and I'm going to cross L at -10, I'm going to cross W at -3 1/3. I wish I hadn't done that, but oh well. So -10, let's say, is out here. And this goes down to -3 1/3, such that I've got a curve. It's coming this way. And love it or hate it, I've got something that now makes me really think about what's going on with my model. And one of the things that I think I may have missed something, up.
I think right there on the 3W% should be a negative.
Yeah, there you go. That's going to save me. That's going to save me somewhere. So that should have been a positive now, which means that's a positive. Cool. So -10 and 3 1/3. And so it's going to cross here, which is a little bit different, right?
I'm just going to step out really quick. I just got to run right up here to the track station and pick up my wife from there.
Certainly. So does this make sense to us, Claire? Well, it kind of does, because what we know is that we have a W star at 3. Okay? Between 2.5 and 3.5. We have L star at -1, which is a little bit of a screw up, but it is what it is, at -1. So that makes sense to us because we're between 3.5 and 2.5, we're between 0 and -10. It makes sense to us. Like it or hate it, it is the labor market that's related or has resulted from these two equations. So how might we interpret that? We have a positive wage and a negative labor unit. What kind of a market might that be?
A non-existent one.
You know, I'm not sure that it is non-existent. It wouldn't be a market for volunteerism. A market for volunteerism would be a positive number of labor units and a negative wage, right? Because when we volunteer, we're amateur or something, what have you, we typically pay all of our own expenses, and we certainly don't get paid, so that's a negative wage. Could this be that we're willing to pay some positive to get rid of some kind of worker? Could this be a criminal? And this is what we're willing to pay into law enforcement and incarceration? So we think about this as when labor is a good. Is it possible labor is a bad? Well, it's possible labor is a bad. I think we would agree there are some type of workers that are bad workers. I'm pretty sure that drug dealers, sometimes politicians, right?
There you go.
From my perspective. I'm now concerned they're taping this, but that's okay. So even though I didn't intend for this to have a perverse relationship, I was hoping it was going to cross in positive space. I just didn't set it up well because I did it off the top of my head. But even though it crosses a negative space somewhere, we can describe it. And we go to some length in the videos to have that discussion as well. Well, we haven't talked about tables, and we haven't talked about elasticity yet. So what I'd like to do is I'm going to pause the video because I want Don to be able to be back for us to talk about elasticity. Because that's something he, for sure, wanted to discuss.